Hello everyone, and welcome to I am your data scientist.com. This is Yogesh. Today is 1st of October. Time is in the evening, 7:30, and I'm recording this tutorial. This is part of a series on data science London Borough crimes I did earlier. So this is part 2. For part 1, please visit or click here. I will also paste this link in the comment section, so check out for that. So earlier for part 1, what we looked at was just explore the data, drawing some histograms and bar graphs and so on and so forth, to know what how the data looks like, how whether it's left skewed, right skewed, so on and so forth. For this is the slightly advanced tutorial on data science in crimes in London Borough, part 2. So let's further ado, let's go ahead. And so let's first clear the memory. By the way, you can get the dataset from this website, and here's the link. You can just literally copy and paste this link into URL. I'll also share these links via YouTube in comment section. At the same time, I've got GitHub accounts. I'll be also sharing this code, well as the links and all that code of our to do this tutorial. So let's call in this CSV. Let's look at the structure of the data, how it looks like. Seems like it's got, as usual, it's got borough, major crime category, minor crime category, and it's got 2016 August up till July 2018. By the way, there must be there's another new data set available which has which the date ranges from 2016 September till 2018 August. So this is slightly outdated, so you can use new updated version. So we looked at structure of the data set. Very important thing here is that I was getting error. You'll be seeing this error in my GitHub account under errors. I was getting error because I was calling these two libraries. These are two different libraries. What we need is R-shape 2 library. So let's call that library. So this data set is only a kind of snapshot selected from August 2017 till then March 2017, March 18, and June, July 18. So this is where I'm subsetting data. So in SQL, if you have say 100 columns, and if you just want to select 10 columns, so you would just what you would do is you just name all those columns, select saying column 1, column 2, 3, 4, 5, 6, 7, 8, so on and so forth from table name, and you just hit run, and it will retrieve all that column. So this is the same thing basically here. It's subsetting the data set. So if you were to look at subsetting, there you go. So now we've got borough, then we got minor crime, then we've got major crime, then minor crime, then all the dates. And you can also see there's about 1053 observations, which is row, and about 8 variables. So 8 columns. So you can see 1, 2, 3, 4, 5, 6, 7, 8 variables, 8 columns. So what we're going to do today is we're going to calculate average crime for borough, for major crime, and for minor category crime. So how do you do that? So let's first we need to melt the data. So melt as in like spread the data. So how do you melt the data? So this is how you melt the data. Melt the data by Borough, and you will get these warnings which saying attributes are not identical across measure variables, they will be dropped. So then let's call that and let's see what we get. So you can see all this, apart from instead of columns, now it's in a row, all these dates. So before we had 2016, 17, 18 March, 18 July, 18 June, July, and all that. So now it's kind of transposed into 3 columns. 3 columns being, let's have a look. So it's got Borough as in Borough ID, then the variables, all these variables, then the values, which are values under the these dates. So now for each column should be listed vertically. So you can see it's listed vertically. Now let's now what this does is we also need to, while transforming, it must have left some nulls into a NA values which we want to get rid of. So this is how you do it. At the same time, call that as numeric, and so this is how you do it. And step 2 is, once it is done, we need to cast it back as it was again. We need to cast it back wide again, or to transpose it back again, and filter with, this is what this will have is, this will have a column for each of the fields we filtered, and will now contain the average by Borough. So at the same time, we'll also rename all these columns. So renaming, saying Borough average 2016 August, so and so forth, till Borough average 2018 July. So let's decast. Okay, so that's decasted. So you can see now for each Borough, you've got average of each month. Now step 3 is to, let's do the exactly same thing with the major crime average. So first we melt the data, then we subset data, then remove the NA data, then convert that into numerical, then decast again, then omit some of the data, then again get the data order, then let's see if that works. So remember, this time we have melted data using 2 IDs, so Borough and major ID, because we wanted average ID for a particular Borough and for a particular major crime. So let's do that again for a minor crime. So first we melt the data, subset data, omit any non-A, then numerical, decast, then column, and you can see. So you must have noticed that now the row before was something like 1,000, then when we transposed it became about 4,000. Now it has become reduced down to 928 rows. So what do we do now? So what we do now is we want to, so remember we had 3 columns, 3 averages, one for Borough average, one for major crime average, one for minor crime average. So what we want to do is we want to join all that together. So That means we want to have, for each borough we want to have its average. For each borough we also want to have its major category average. The same time we also want to have its minor category average. So we kind of joining all that columns we've created horizontally rather than vertically. Not vertically but horizontally. So if you put left hand side and from right hand side, so joining them together. So first one, the borough average, major crime average, then the minor crime average. So let's see how that looks like. So you can see here, so that's all the borough average for five dates, then the major crime average, then the minor crime average, you can see here. So you must have noticed that again, that the observation gone back to slightly higher, which is 1010, and which has also removed some of the which didn't had any averages. So now step 5 is to put 5 placeholders. So let's put these new fields to use. We have just created all these 15 different columns. So let's first we'll add 5 placeholders or variables which contains 0 as a default, so we can track whether a borough is under or a less or a high crime or over crime based on being lower than the borough or a major crime average, major crime category average. So how do you do that? So within that data set, we want to call a column saying borough average, borough 2016 August under, then March under average, then 18 March, 18 June, 18 July under, then same thing for major crime category, and for the minor category. So now what we want to do is we're saying step 6 is we will replace the zeros with ones wherever the respective value of the crime is less than the average, to indicate that this crime might be above average based on the metrics. So we're saying if the average is above the total average of a crime, then we will put place 1. So let's do that for borough. We also do that same thing for major crime. Then so finally we will have a 15 columns to create a new column with the index value stating 1 to 10. So what it will do is it will say how high crime is based on different dimension that were considered. So we given a borough, how high is the crime, how many crimes are committed in each borough. So to do that, what we do is we create a column on a fly and apply that. So remember we had about 30, now currently we've got about 38 variables, and we had about 15 columns created, we said. So what we want to do is from 38 minus 15 is 23, if my maths are correct. So what I'm doing here is I'm saying all those 15 columns, I'm saying sum them up and sum that into this column called real crime index, and I'm saying, let's say if I want a real crime index greater than 500, and if I was to return that, see what crime. So you can see real crime index is about 500, and all these are greater than 500. And interesting to notice that there's a row ID which is 141. Let's have a look. What is 141? Which is Westminster, and Westminster is got highest crime rate index, so which is very, very surprising to me, basically. And Westminster, and again that is theft and handling, and other minor crime category, other theft category, which is quite high for some reason. So Westminster is at the moment considered to be very high in crime in London boroughs. So that's the one part. So you can decrease that to, say, give me top 10, or you can do further. All those real index you can see, and about 1,228 rows. And if you want to download this CSV, you can just download this here, and I think I've downloaded where it has downloaded. So if you want to further analyze data, you can just I usually use Tableau to visualize data properly. You can use again R, Gplot, and so on and so forth to see how data looks like. But I'll just connect this and see if that makes any sense. So the column we calculated was real-time index. Let's look at the Borough, and you can already start see. Probably you have already started seeing that Westminster is quite high, as expected. And if I just to make it slightly readable. By the way, I will also do a tutorial on Tableau and SSIS package and all that. So stay tuned. So you can see here Westminster is quite high on crime index. And there's another one column which is, you can see again, it has sorted alphabetically the numbers, but you can see this is the key thing here is, which is quite high. So again, this is just a very basic, as in like intermediate data science tutorial. For more advanced, I will also record some more on K-means clustering and hypothesis and decision tree and so on and so forth. So thank you for watching this video. Hope you've learned something from it. I have learned quite a few things. And thank you very much for watching this tutorial. So by the way, I will also, as I said, I will also be sharing all the codes and the data set itself. So stay tuned. This is I'm your data scientist. This is Yogis. Thank you very much for watching this tutorial. Bye.